My name is Chris Cook. I'm the Managing Director of the Office of Communication and Marketing at Texas Tech University and Texas Tech Public Media. Texas Tech University is full of great communicators, and together we hope to bring you perspectives and insight that can help you in your field. Communication is what we do every day, and it's intricately connected to our success and failures. This is Communicators in a Cart. Dr. Alessandra Corsi is an astrophysicist in the Department of Physics and Astronomy at Texas Tech University. Recently, she and her colleagues detected radio waves from the merger of two neutron stars, an event she says will change the way we do astronomy. I'll let her explain the details. Dr. Corsi, how are you?
I'm doing fine. How are you?
Good.
Good to see you.
Congratulations on your recent discovery.
Oh, thank you.
Can I buy you a congratulatory cup of coffee?
That would be awesome.
All right,
yes.
let's go. Great.
Oh.
We're in the red cart.
And it's red and black.
This is a different cart than we usually use because the president's cart is being used for VIP tours today.
Oh, wow. I've never been on a golf cart.
You've not been on a golf cart?
Nope.
Okay. Well, it's, just like a Jeep, but smaller. Are you a sports fan at all?
Oh, unfortunately, no. I don't understand football, by the way.
So, like when you say football, American football
Yes.
or European football? Okay.
Well, I don't understand either, but yeah, I'm more used to the European one.
I just mentioned that because we're about to go by the stadium and it's,
Yes.
we have a game
But
tomorrow.
I think I should go once in my life.
Yeah, just
I'm
experience
curious.
the atmosphere.
Yeah.
Yeah, sure. All right, so where in Italy are you from?
So from Rome. I was
Oh, from Rome.
born-
Okay,
Yeah,
yes,
actually
okay.
from there. Yeah, I was born there and did all my studies there.
So you were going to be a physicist in Italy?
Yes, an astronomer and astrophysicist in Italy. And then by the time I ended my PhD, I came a couple of months in the US and then realized this is so great.
Yeah.
Started going.
Well, good. Well, we're glad you like it. And
Yeah.
Texas Tech, I know, is fortunate to have you here. So.
Texas Tech is a great place to be.
So in the field of physics, astrophysics, when I think back, I think back to Galileo.
Yes.
And he was an Italian scientist, as are you.
Yes.
What foundation did he lay for the field of astrophysics?
Yeah, well, I would say Galileo was the first to point the telescope at the sky, so he didn't invent it, but he opened a completely new view, what's up there. And we're enjoying something similar now with first gravitational wave detectors looking at the sky and detecting stuff for the first time.
So outside of the casual stargazer like myself,
Yeah.
what's out there? What's fun to explore?
Well, so thanks to this new detectors that we have, there's a lot of smashing things. There's like black holes colliding with other black holes and neutron stars, this really dense dead stars that are smashing each other. It's a violent universe out there.
Well, speaking of neutron stars, recently you served on a panel with
Yes.
the National Science Foundation had an announcement, and you were part of a collaboration with other universities and scientists. Tell me about the discovery.
Yeah, this was just such an exciting moment. So what we discovered was a pair of neutron stars. So these are like around the mass of our sun in a region really compact, 10 kilometers, and they were dancing around each other and they happened to smash each other. And LIGO and Virgo gravitational wave detectors were on, and they heard the ripples in space-time coming from these smashing neutron stars, and then we also saw light. So going back to Galileo, many telescopes were pointed at this event, and it was just amazing. So the first time we ever detect gravitational waves and light from a cosmic smashup.
What significance will that have? And I remember having this discussion a while back, and one of your colleagues talked about the significances it have on future research. But
Yes.
not just on future research, but in textbooks and physics
Oh,
textbooks.
yes.
So what's the
Yes.
impact this will have down the road?
For me, I honestly think this will change the way we do and teach astronomy, because with Galileo, the traditional cosmic messenger has been light. Light brings us the information about what's out there, the stars and in the universe and galaxies and so on. But now we have another messenger. It's like using both your eyes and your ears. So now with gravitational waves, you're also listening to these ripples in the fabric and space-time. So there's probably stuff out there that we've never seen, and it's just we're gonna learn so much more by combining light and gravitational waves that it's just a different way to do astronomy. It's just a new era, I would call it.
How far away we're talking? This isn't the other side of the moon.
No, this is like 130 million light years away. So if you have for a physicist that studies our galaxy, it seems pretty far away. In extragalactic terms, it's not that far away. So this turned out pretty loud in the data. So, but absolutely, this is away from our galaxy and like pretty much a far away distant galaxy where this cosmic smashup went off.
And you guys are, not that the physics program here hasn't been good, but a lot of what you guys are doing, the collaboration with some of the top universities in the world,
yes,
is Texas Tech is getting mentioned up there with
absolutely.
these
We're very proud.
top institutions.
Yes. Texas Tech, I think, had they saw the opportunity before this discovery. So in 2014, we started this gravitational wave, and the astronomy group really started a year earlier than that. But Texas Tech decided to invest in this field before it boomed. So the big deal was, okay, now in 2017 we have this huge discovery, and TTU had the right idea to invest in this. So now it's easy to recognize the field as booming and growing and absolutely awesome. But it wasn't that evident in 2014, I would say.
So MIT, Harvard, Texas Tech. That's awesome.
Yes.
I like how that sounds.
Yes, sounds good. Yes, we're looking forward to growing more, and there's a lot of potential here.
So what's next? Or do you continue researching this, or are there other things you're looking for now?
So I think next summer the gravitational wave detectors are going to be back on. Now they're switched off for improvements and so on. But we expect that starting next summer, this type of event is going to become routine. So now, when this happened, I was like, reducing data at night, teaching in the morning. So if this happens, monthly or every day or weekly or something like that, I think we're going to need a lot of students. So
it's a little sleep. It sounds like a little sleep.
Plenty of PhD thesis is next.
Okay, so as a layman, as I think most people are when it comes to physics and astrophysics, my education comes from, it's just like my education in the opera comes from Bugs Bunny.
Yes.
And okay. But my education in physics comes from Big Bang Theory.
Yes.
Not a book, not anything in the classroom, but
yes.
the sitcom.
Yes.
So obviously, most of that is inaccurate, I would assume. But the question that always comes up when I watch this is why the animosity toward geology?
Oh.
Is that true, or is that just in this show?
That's a good question. So I can tell you my personal story. I actually wanted to be a geologist when I was in high school. I wanted to study volcanoes, so explosions on Earth. And then, going through, I changed my mind, but I stayed on the topic of explosions, and now I'm looking at them in the sky. So I like geology. It's fascinating. But yeah, maybe there is a little bit of that.
Maybe more of an old folk tale, but there might be
a bit of that, maybe.
So in 2015, you received an Nsf Career Award. What has that done for your research in just 2 years?
That was a big deal. So it was this award was exactly for finding radio light from gravitational wave source. So exactly what happened with the two neutron stars matched up, and then we got the radio glow. So for me, this discovery was like the dream come true. So what I promised in that award, there it is, that we would do and we would discover. So it has supported me, and it was a big deal to keep doing this until we reach this discovery. So that's something that's going to continue until 2020. So we have more to do, but it was a great start.
Well, so the Nsf Career Award is a big deal. And
yes.
I know we have several faculty across campus
yes.
in different disciplines that have received
yes.
those. But so to be able to convince that group, because that is highly sought after
yes.
around the country. There are thousands of researchers
yes.
out there
yes.
vying for those.
Yes.
Can you reapply after 5 years, or is it a one-time?
Yeah, the career is a one-time thing, but then obviously you can continue with the National Science Foundation.
It could lead to other opportunities.
Absolutely, yeah. I think it opens many roads. I mean, and the nice thing about it is that it's 5 years, so you get you can plan long-term. which is different from usually standard awards are 3 years. So for someone that is new and is navigating through the new career as a professor or researcher is very important.
Can we call you and your colleagues rock stars in the field
Oh,
of physics?
if
Can
you
we
like.
use that when we talk about our physicists?
Maybe I would say we're starting to get there. Yes, why
Good,
not?
That's awesome. Dr. Corsi, thank you
Yes.
so much for
Thanks a
your
lot,
time. I've
Chris.
enjoyed it.